All right, guys. So asked you guys to draw 4 lines on 2 different separate grid papers and make some conjectures. So did everybody get a graph, 2 lines that look like this on the first one? Right? If you didn't, that means somehow you didn't do your rise and your run properly. Okay? Because again, if you need a reminder of how to graph that first one, okay? So that y equals 2 over 3x minus 1, you would have plotted your point at minus 1, and then you would have went up 2 over 3. And you could have done that a few times. Or down 2 and back 3. Okay? So have your 2 lines. What did you guys notice about them? Right. So we're used to that word, right? Is everybody used to the word parallel? Okay. So again, parallel just means 2 lines that run side by side that never ever cross. Right. They never ever cross. Right. So they're parallel lines. Now, what do you notice about the equations? Hopefully this kind of jumped out at you. What do you guys notice about the equations? Right. And would that make sense that they would have to have the same slope if they're never going to cross? Yeah, because if they had different rise and runs, okay, at some point they would have to cross, okay? It might be a gradual, but again, they have to have the same slopes. Okay? So if they have the same slope, but different what? Y-intercept, because if they have the same slope, same y-intercept, it ends up being the same line, which we'll actually talk about that, but not today. Right, so they have the same slope, different y-intercept. Right, so that's what we notice about these 2 lines here. Okay. Now, the next one might have not been as obvious, especially if you didn't use a straight edge. Okay. Right, but if you used a straight edge, I'm hoping you noticed that they did cross, okay, but it was a specific angle that they're crossing at. Did anybody have lines that looked perfect enough that they could make this connection? Right, you did? Okay. So if, like I said, I was going to say use a straight edge, but then it was too late. You guys, half of you were done already. Okay, but I promise you, if you used a straight edge and you connected the dots perfectly and you took a protractor and measured the angle where they cross, I promise you it would be a 90-degree angle. Okay, so I have one right here if you want. Oh, yeah, if you go right around there on the bottom. It's weird, it's under my desk. Keep going. You're like, it's so strange back here. You're welcome. All right, so it isn't a coincidence. They do cross at a 90, these 2 lines. So therefore, what do you notice about the line? So if you didn't notice, I promise you, with a straight edge, you took a protractor, it would measure. And remember, guys, have you guys seen that before, a little square? Right. Where have you seen that before? Right, in a right angle triangle. You've seen that a lot. I put it on the top there, but does every single, because do you guys agree that there's 4 kind of sectors at where they cross? Are all 4 sectors 90? Yes. So I put it in one, but just realize this is a 90, this is a 90, this is a 90. All of them are 90s. All right. Get rid of those. So what do you notice about the lines? That's what we'll do about the slopes. Yeah, so let me write this one in. So what do you most about the lines? So they intersect at a 90-degree. And what did you just say? What word did you just use? Right, so that's what will be the slopes. But have you guys heard that before? So if they intersect at a 90, the lines are perpendicular to each other? Okay, good. All right. So now, Joshua, what are you saying about the slopes? What do you notice about the slopes? Exactly. Okay. Are we all confident with that word? So he said they're reciprocated and one's a negative. Okay. That's perfect. That's what you need to look for. So if you have slopes right in front of you, right? So if they're reciprocated, which just means what in layman's terms? Flipped, right? So if you have a 1/2, I flip that, you get a 2, right? If you have a 5/4 and you flip that, you have a 4/5, okay? But the other piece of information he said was one of them has to be negative, which again, that hopefully makes sense too, because, right, are those slopes different? Does one have a positive slope, one has a negative slope, okay? So perpendicular slopes are negative reciprocals of each other, right? Or you can just write it out exactly how he said as well. One slope's positive, one slope's negative, right? And they are reciprocals of each other. However it's going to make sense, you write it in your words. Some students say, instead of say reciprocate, guess what word they use? Flipped. Am I okay with that? Yeah, you just need to write it in terms that when you read it, it's going to make sense, okay? Do I still need you guys to understand what reciprocal means? Yeah, so that's a word that's going to come up lots in our course this year, next year, and the following year. So it's still important that you understand what it means, but these are your notes. If you want to say flipped, say flipped. Okay. So what do you notice about the equations? Right, the slopes are negative reciprocals. That's how I'm going to say it. You say it however you want. Now in this situation, are the y-intercepts different? Yeah, but do they have to be different? No. Right? They wouldn't have to be. The main thing is the slopes are negative reciprocals to each other. So that just means one has to be positive, one has to be negative, and one slope, the other slope when you look at it has to be exactly the same except flipped. Okay, that's what you're looking for. Because you will be asked, guys, like I will give you two linear equations and I'll ask you, are they parallel, perpendicular, or neither? Okay, so again, keyword here, these guys are parallel, and these guys are, what word am I going to use? I'm not going to say they cross at a 90. I'm going to say they're perpendicular, which then you make the conclusion that they cross at a 90. Okay. So again, fill these little guys in. So parallel lines have what blank slopes? Same, right? What's another word I could use? Equal, okay? Identical, however you want to say it. Okay. And perpendicular lines have slopes that are negative reciprocal, negative flipped, whatever. All right. So that information is key to be able to answer the style of questions that we're going to do next. Okay. Bless you. So this just kind of, on the next page, guys, this basically reviews what we just talked about, except, okay, lines that are vertical or horizontal, okay? So did we talk about lines that, for this situation, doesn't have a slope? Well, it does have a slope, but what's the slope? It's undefined, okay? So can we still have undefined lines that, or sorry, undefined slope lines that can run parallel? Yeah, you just have to have, write another, what kind of equations are vertical lines? That would be the slope, but just in general, if I said, if I wanted you to write an equation of a vertical line, nope, stop thing, what axes does it intersect? So it's definitely intersects the x, right? So it's a x equal equation. Should you guys be able to draw both of, write the equations of both of these right now if I asked you to? Yes. The red one would be what? X equals 2. Right, so if I give you an x equal equation that has an undefined slope and I ask you to write an equation that's parallel to it, you just write another x equal number. That's not, in this situation, a 2. Okay, so this would be x equals -1. Okay, but what about if I have a vertical line, right, so with an undefined slope, and I ask you to write an equation of a line that is perpendicular, what would you guys have to do? Right, a y equals, right? So a y equals that has a slope of 0. So an x equal a number and a y equal a number, okay, will be perpendicular to each other. Can you guys visualize that? So I think there's a picture. Yep, right here. So that would be that example. Because again, the red line is what equation? Right, this one is x equals 2 because it has an undefined slope. Right, and then the blue one is y equals 1 because the slope is 0, so we don't have to go 0x. But technically, would that be the same thing? Yeah, it's just 0 times x is 0, so there's no point. We simplify it just to y equals 1. So that's kind of neat. So those are kind of our outliers, our verticals and horizontal. Majority of the questions you guys are going to be doing will actually have slopes. Right, so you're going to have to analyze the slopes to see if they're going to run parallel or perpendicular. All right, so here it just says for a line with each slope given below, give one example of slope that is parallel to it, then one that is perpendicular. Just to make sure that we're confident, without anything else around it, graphing or anything, that you all can pick out slopes that are parallel or perpendicular. The thing about this one is, guys, could you all give me different answers for this table? You could, okay? Because we know that if we're doing parallel slopes, what should the slope be to the original? Should be the same, right? And when I say the same, can I say equivalent? Would that be another word, right? I can say equal. So if we're just kind of not wanting to be creative at all, which I'm completely okay with, can we literally just write down exactly the same thing that's there? Yeah. But could we be creative and write something that's equivalent to exactly what's there? Yes. So that's what I'm saying. So I'm going to write a couple just to show you what I mean. So if you literally just wrote m equals 3 over 4, am I happy? Yeah, it's the same thing. Could you write 0.75? Would that be equivalent? Yep. Could you write 6 over 8? Do you see where I'm going with this? Right? There's infinitely many equivalent fractions to 3 over 4 that you could write down. I don't need you to be creative, right? If you want to be creative, great. But I am completely okay with you writing 3 over 4 again. Okay? That tells me that you know that a slope that is parallel is exactly the same thing. Okay? All right, so my perpendicular slope. So what am I doing with the 3 over 4? Right, turning it into a negative and flipping it. 4 on top, 3 on the bottom. So that means flip, which means reciprocate. So whatever's there, you need to flip it. If the original's positive, then the perpendicular one needs to be negative. So is it a little bit more complicated to, if it's in decimal form, to reciprocate that? Yeah, I don't want to see this. That's, again, even though, is that technically correct? Yeah, but do I want that? No. If you're going to do something like that, I would hope that you would put it into your calculator and simplify it back to fraction form. So I do want, because to me a slope of 0.75, that's still technically a nice terminating decimal, but as soon as you reciprocate a decimal, put it into your calculator, simplify it, and guess what it'll simplify back down to? Negative? It won't simplify to 0.75. It'll simplify to negative 4 over 3, which is a negative 1.3 repeating, which I don't want a repeating decimal. So then you leave it as negative 4 over 3. So we're not going to get fancy with that. Even though you could do negative 8 over 6 and stuff like that, but we'll keep it simple. All right, so parallel slope to 2 would just be 2, you betcha. Could I say 8/4? See where I'm going with this? There's infinitely many answers you could write. We're just going to keep it simple. And then perpendicular slope, though. What happens when I flip that? 1/2 and negative. Good. So please make sure, guys, just think 2 is still a fraction. We just don't write 2/1 because 2/1 simplifies just to a 2. But you still have to visualize that when you reciprocate, right? Because again, 2 is still 2/1. 2 now needs to go to the bottom because we're flipping it, but then what has to rotate to the top? A 1. Okay. So that would be your perpendicular slope. And then negative 1/4. So again, parallel slope means the same. So we'll just keep it simple, write down exactly what's there. And then, what are we doing again? Reciprocating. And turn this one to a positive, exactly. Perfect. And again, you could write that, but guys, should you be simplifying that? 4/1 is just 4. Right? And the original was negative, so the perpendicular one is positive. And the reason why we're kind of going through this, you might think it's simple, okay, hopefully it is okay, is because we will be writing equations of lines. Okay, so I might ask you, what's the equation of a line parallel to this line? Right, so if I ask you that, then you have to take the slope from that line, right? And you need to know, am I taking the slope exactly as it looks, or am I flipping it and changing the sign? Depending on if I ask you, write an equation that's parallel or write an equation that's perpendicular. So you need to actually be able to do this. Grab the slope from an equation and decide if you're using exactly the same slope or the one that you're flipping and changing the sign on. No. All right, so then if I tell you that you have a slope of undefined and you need to tell me a slope that's parallel to it, it would stay undefined.
Could you like an example?
Yes, I'm going to do that, you betcha. So I will write an example with actual numbers here just to remind you what undefined means. So undefined in your fraction means the zero's where? Right, on the bottom. So does it really matter what number I put on top? No, so let's use a 3. Okay. And again, the number on top doesn't matter. Okay. So then, obviously now, if we flip that, okay, does the positive versus negative matter here? No. Okay, because 0 is just 0. All right, so therefore for here, we know that if we flip an undefined slope, that will give us 0. So 22. That will look like a 0 in a second. Try that again, see if it'll work. There we go. And I know I don't have to write the word. I just felt weird writing a word on the other column and not a word here. Which just means 0/3, which just simplifies to a 0. Okay. So again, undefined line, vertical. 0 slope, horizontal. So they will be, okay, those would be fair questions, right? For me to ask you to write an equation of a line, if I give the original one, that starts with a vertical or horizontal. Yeah.
Did you say that there is no negative 0?
They're the same. Just because you can't, because remember guys, like if I say 1, that means it's 1 unit from 0. So if I go -0, right, 0 is just 0. I have students that bug me all the time and then write -0. I'm like, anyway, that's a long story. It's more to just bug me because they think it's hilarious. All right, so example 2 just says state whether the lines in each pair are parallel, perpendicular, neither. So we will study systems in chapter 8-9, right? So right now you're just looking and you, by studying it, telling me whether they're going to be parallel or perpendicular. Yeah. Pardon me? Yeah, if you need to. Yeah, not feeling well. All right. So if you're asked to tell me which one they are, what do you basically need to look at? Yeah, you need to look at the slopes. Okay. So in a lovely world where everything's perfect, is this one really quick to tell whether they're parallel and perpendicular? Yes. But as you guys know, not everything's going to be rearranged, so you can look at the slopes really quickly. Okay. So the work for this one, not really that there's work. I would just grab the slopes to make sure that you're analyzing them perfectly. So the first one has a slope of 3. The second one has a slope of 1 over 3, but it's a negative. Right, so that's what you're looking at. Now can you tell for sure if it's parallel or perpendicular? Yes. So ask yourself, are they the same? Are those two things the same? They're the same? Definitely not the same. Right. So that's kind of your checklist. I always ask myself first because the slopes sometimes aren't going to be simplified. So you always have to simplify your slopes so they're reduced all the way down that they possibly can. Okay. And then you ask yourself, are they the same? So the first one's a 3. So is the second one a 3? No, it has a 3 in it, but it's not a 3. Okay. So they're not the same. So they're not parallel. So then you ask yourself, look at the first slope, flip it. So if you flip a 3, you're now at a third. First one's positive, second one is negative. So does it meet their criteria? Yes. So it meets the criteria of being perpendicular. So you could write the word, guys, but if you write an upside down T, oop, not a plus. Try that again. Right? So this is the symbol for perpendicular. If you write that, I know that you mean they're perpendicular. I'll write both. Yeah. Yeah, 2 lines beside each other. I'll do that one when we get to it. Yeah. So that is your symbol for perpendicular. If you use it, I'm okay with it instead of writing the whole word out. But either one. Okay. So this one, again, you do have to be careful because we have one equation rearranged for y equals, but the other one, is it rearranged for y equals? Right, it's in general form. So please make sure before you start, everything's in y equals. So do I have to move that 3? Or sorry, not move the 3. Move the y? Yes, so move the y. So it's negative on the left, so it's going to become positive on the right. This one, like I said, only had a kind of one step that didn't actually affect the slope. But most times, guys, when they're not rearranged, it's affecting the slope. So you can't just look at the numbers on the x. Even though in these first 2 cases, I'm going against what I just said. Majority of the cases, this isn't going to be the case. So those are my 2 slopes. Are they the same? Yes. If, guys, let's just pretend, don't write this down, but let's pretend I had y equals 3x minus 1, and once you rearranged everything and you had y equals negative 3x plus 7. What would you guys tell me those were? Neither. Okay, good. Sometimes I have students say that that's perpendicular. Okay, is it very clear it's not perpendicular? Okay, you're gonna not like me. How about this one? Y equals x plus 4, y equals x minus 7. Sorry, negative x minus 7.
I guess it's perpendicular.
That one's perpendicular because if I actually write the numbers out, okay, what's the slope on the first one? Right, the first one has a slope of 1 over 1. Even though, would we ever say 1 over 1? No, but that's how we have to picture it, okay? Because again, even though there's no number written there, is there a number there? Yeah, so for the first one, it does have a slope of 1 over 1. The second one has a slope of negative 1 over 1. So are they negative reciprocals of each other? Technically, yes. Okay. So that's not a trick. It's just you got to think a tiny bit with that one. Because Again, if I put a number other than 1 in front there, are they neither? Yes, because if you flip a 3, you get a third, right? The only number that you can flip that you end up with the same number is a 1. Okay. So, kind of neat. Interesting. All right. Okay, so with this one, again, nice with the first one. The second one, because this is a common error I have students do. They just do this. Go, oh, I'm just going to look at the numbers on the x's. Okay. The only time you can do that is if the equation is simplified. It's rearranged for y equals mx plus b. So the y has a coefficient of 1 on it. Okay. So the first one, yeah, absolutely has a slope of 2. But the second one, you have to manipulate that. Right? Right now, the y has a coefficient of 3 on it, and it's not isolated. So you have to have it in y equals mx plus b form. So you guys have the skills. It's just a little bit of work. So this one I would probably take, just because I don't want to move a lot, can I just take the 1 term over?
Yeah.
Right, so I could just move 1 term. So then I would get a negative 3y, and then I would divide everything by negative 3. Please make sure you always simplify before you talk about your slopes. So 6 over negative 3 is negative 2. So we have negative 2x plus 3 minus 3, not that I care about the y-intercepts, but minus 1 equals y. Now we can compare the slopes. Right, so I have a slope of 2 and I have a slope of negative 2. Okay. So they're not the same, right? Because I know they both have 2's, but one has a negative, so they're not parallel. And are they flips of each other? No. Because 2, if I flip it, is now half. So therefore, these would be neither. Right? So they would they intersect though? Are the slopes different? Yeah, they have to. If the slopes aren't the same, they have to intersect. And that's what we're going to do in chapter 8 and 9. We're going to actually graph these and find that intersection point. But that's in the future. Oh, sorry. I said I was going to tell you and then I didn't. Okay, I apologize. And I didn't even write it down that they were parallel. Okay, so parallel are literally just 2 lines that are a little bit slanted side by side. Thank you for reminding me. Right. So again, you can use your symbols instead of writing the whole word out. It's very quick. Right. All right, last thing I want to do with you guys is it only makes sense that you have to write equations to be able to find pieces that are missing. Okay? So what I mean by that is if I give you a slope, okay, and I give you a partial slope, should you be able to figure it out if I tell you that they're parallel or perpendicular to each other? Right? So that is what we're going to do now. So do you guys agree that I gave you a slope? For the first one, I'm giving you n over 7, and I'm giving you 3. Did I give you one completed slope and one partial slope? Yes. So if I give you one completed slope and one partial slope, you should always be able to find the unknown as long as I tell you if these slopes are parallel, what do we do? Right? If these slopes are perpendicular, how do we solve it? So students always love the parallel ones because what do we know about the slopes of parallel? They're the same. So what can we can take those 2 slopes, break them apart a tiny bit, and put what between them? An equal to sign. Do you guys agree? Because parallel slopes are equal. So if they're equal, did we just build an equation? Yes. So again, take your slopes, part the c a little bit, just to give room for the equal to sign, and then there's your equation that you're solving. Right, so n. And this one, I know some of you, could you just common sense what n is going to be? Yes. But do you think I'm going to give you numbers that you're not going to be able to just do it in your head really quick? Yes. So I want to do the algebra, okay? Because, again, do you guys know what number divided by 7 is going to give you 3? 21. I get that you don't need to do the algebra for this one, but like I said, sometimes your value is going to be like 2 over 7, right? They're not going to be nice numbers. So want to make sure algebra is sound. So is this still just a one-step equation? Yes. So how to solve for n? I multiply by 7. Exactly. Right, so two different ways to look at it. You can multiply 7 on both sides, right? Or can I just multiply the 7 off the bottom because it's in division form over? Either way, does the same thing. So n equals 21. I'm going to do both the parallel column first. Well, there's only two. So with this one, do you agree that it's a little bit more complicated to see just visually? Yeah. But again, could you figure out the ratio? You could. But will the algebra lead you to a beautiful place and solve for n? Yes. So the algebra is going to look very similar. Okay, so we part them. What do we put in between them? Equal to signs. So we have 4 over 5 equals n over 12. So I want n by itself. So really, what's the only number I need to get rid of? Yeah. Could I just cross the 12 over? Right? You could cross multiply, but to me, am I done in one step if I just get rid of the 12? Do I have n by itself? Because just to show you guys, this is what sometimes students want to do, which is okay. It's not wrong. You just are creating more steps. Is that where you guys were kind of thinking that's what cross multiply would look like? It's not wrong, but technically, can I just multiply the 12 across and be done in one step? And is that the same thing as just multiplying both sides by 12? Because the 12s divide out on the right-hand side. And then that's going to give me, and again, if you did it the other way, guys, it's the same thing. If you cross multiply, then you would end up having to divide by the 5, right? Because the 5 was on the end. And technically, if you look at that, is it divided by 5 already? Yeah, it's just saving you a step is all. Right, so then we can go 12 times 4 divided by 5. So 9.6. So it's a terminating decimal, so you can leave it as a decimal. So before I do perpendicular, guys, let's pretend the n was on the bottom for 1. Oops, that's a horrible color. So what if we had like 2 over n equaled, whatever, 20 over, that would simplify though. Let's do 13, just so it doesn't simplify. So if the n's on the bottom, are we okay with this one? Because with this one, do we actually have to do more than one step? So this one, we do have to multiply the n over, and we should multiply the 13 over, just so I don't have to touch my calculator. So this one, I'd multiply the n over to the 20, and I'd multiply the 13 over to the 2. So this one, I would cross multiply. So then I would get 20n equals 26, and then n would equal 26 over 20, which would be 13 over 10. Okay. That was for parallel, because I just put an equal to sign in between. All right, I just wanted to show you guys what happens, because when the n was on top, could we just do it on one step? Yes. But if the n's on the bottom, so I just randomly picked one where the n was on the bottom. Yep. Oh, all of them you can common sense and figure out the ratio. Yeah, because that's like this one. Could you do that without doing any algebra? Yeah, so same idea. You're figuring out the multiple of it, right? Which does the same thing. My only worry about that is if it's nasty and you can't do that in your head, do you know the algebra on calculating it? Does that make sense? Right? Because if I would have put like the 2 as a 1.7, then would you go through this process? If I put the 2 as a 1.7, would you be able to reason your way through? No. Pardon? Oh no, you can always figure out the ratio, because it's a ratio from one fraction to the other, but you wouldn't be able to do it in your head. So to me, trial and erroring that doesn't make sense. Algebra, boom, done. All right, so now perpendicular, okay? So we have two slopes. So there's two different ways you guys can do this, okay? Which way is coming to you that you should be doing it? So negative n over 7 equals 3? What are you not doing? Right. Do we need to reciprocate something? Yeah, so this is usually the way students want to do it, which, great success. So you have to pick one of them and reciprocate it, and then switch the sign. Because is that how we know they're perpendicular slopes? Yes. So it doesn't matter which one you choose, up to you. So which one do you guys want to flip, the first one or the second one? First one. Okay, so if we flip the first one, that's now going to be 7 over n. And what do we need to put on it? A negative. Does it matter where I put the negative? No. Guess where I want to put it? On the? Yeah. Do I want to make the variable I'm solving for negative? No. So to me, you could. If you put the negative on the n, you're creating an extra step for yourself, because you have to make sure that when you're done solving, the n is positive. So you have to put a negative with the top or the bottom. So to me, it makes sense to put it with the top number, right? Because we're solving for n, we want n to be positive. And then we can now set this equal to 3. Right, so then, solving for n, we can multiply the n across. So then I get negative 7 equals 3n. And technically, guys, can we use our general form knowledge to be able to get rid of this fraction? Because technically, aren't we just multiplying both sides by n? Right? It's just I'm not showing that work. So the n's on the left-hand side divide out. So I'm still left with an n on the right-hand side. Now I can divide both sides by 3. So therefore, n is going to equal negative 7 over 3. Can you check to see if you did it right? Because that looks like it's not a nice number, but you guys would be able to see if you go negative 7 over 3. I'm just putting it back into my original. So I'm putting negative 7 over 3 in for n. And then I'm going to divide that by 7. Math, enter, enter. Is that slope perpendicular to 3? Yeah, because negative 1 over 3 is perpendicular to 3. So n is beautiful. So I'm going to show you this technique first, and then I will show you one other technique, just because it's interesting, but you can use this every time for perpendicular. So which one do you guys want to flip for the next one? 4 over 5? Okay, so if we flip 4 over 5, that's now going to become 5 over 4. Where do you guys want to put the negative? Because this one doesn't matter. Neither of them are variables. So do you want to put it with the 5 or the 4? 5. Thank you. So then that's going to equal n over 12. Pardon? Oh, it's just separating. That's weird. Oh, of course. Right, so you should see in my brain and out in space, negative 5 over 4 equals n over 12. Right, and then how many steps can we do? We can just do one step. I will reconnect this. Sorry guys, that was weird. Maybe not reconnect. There we go. So 4, 6, 2, 7, 6, 8, 0, 3. I apologize. So by us not flipping the second one, guys, did we actually save a step of algebra if we're algebraically solving these? Yeah, we did. Right? So when you guys decide what to flip, you should be thinking about those things, right? Because if I ended up flipping the second, then the n's on the bottom, right, which creates more work. Here now I can just take negative 5 over 4, and times it by what? Times it by 12. Right, because what's on the bottom? 12, so it has to get multiplied across. So then 12. So when we do that, we're left with our negative 15.
I did it like a block. So if you did like, for example, 4 times 4, it's bunch of 4 and divided by 12, and divided by 12, and divided by 4. Or you multiply by 12 and divided by 12. I mean, I got negative 15.
You could definitely do, because I'm assuming you multiply the 12 across, you multiply the 4 across, and then divide it by 4? Yeah, you cross multiplied. So that's what I talked about before. Could you cross multiply and do this? Because technically, is that cross multiplying? Yeah, right? It's just more steps. To me, if I have n isolated in the numerator and I only have to get rid of the denominator, it's one step, multiplied across. I can multiply both sides by 12 and be done. Yeah. All right, so I just want to show you one more thing, just because it's kind of deep thinking, okay? Another way, which again, students never use, but I still want to show you, is I want you guys to notice something about perpendicular slopes, okay? So with 3 over 4 and negative 4 over 3, okay, what would happen if you multiplied those two together? What would it equal? Negative 1. If you took 2 and times it by negative half, what would that equal? Negative 1. If you took negative a quarter times 4, what would that equal? Do I have to stop? Can I use this example with undefined and 0 slopes? No, they'll never equal negative 1. Right? But if we actually have values for the slope other than 0 or undefined, okay, you could use that, because that's not a coincidence. That's how you can actually check to see if they're perpendicular too, is if you ever multiply the two numbers together and they multiply to negative 1 simplified, that will always be perpendicular slopes. So just to show you that, could you use that knowledge to set up an equation for these? You could, okay? So I'll show you one and then you can decide if you hate it or love it. But you could technically go perpendicular slopes when you multiply them together. So I'm just doing the first one. So when you multiply them together, they always equal what? Negative 1. Okay. So then you would solve this. So this would just be 3n over 7 equals negative 1. Because again, do you guys agree that when you're multiplying fractions, 3 is the same as 3 over 1? So you multiply across. So 3n over 7 equals negative 1. Then I would multiply the 7 across. So then I would get 3n equals negative 7. And then I would divide both sides by 3. And I'd get negative 7 over 3. So most prefer the way we did it in class, okay? But some in the end prefer this way. Both are just techniques, different, okay? But are we still using knowledge of perpendicular slopes in both cases? Yes. So again, I don't care which method you use. And like I said, with this one, just if you want to see what it would look like, you don't do anything with the originals. You just take the originals as they are. So if you did the other one, it would be take the originals as they are, set it equal to negative 1. So then you would have 4n divided by, so 5 times 12 is what, 60, equals negative 1. Multiply the 60 across, negative 60. And then you divide by both sides by 4, which would give you negative 15. Okay. So two different ways, okay, that can work when you're solving for an unknown piece in a slope when you're asked to find perpendicular slopes. Nope. So again, I will not force one method or the other. Okay, just like when you're writing equations of line, I won't force one method or the other. I'll just ask you to tell me what n is. So you technically, guys, could you, for the ones that are common sense, could you just write the value down of the answer and not do any algebra? Like something like this. If I was nice enough to give you this one here, could you give me the answer without setting up an equation at all? Yeah, absolutely. The equations Okay, I've shown you because do you think they'll become more difficult where you can't just do it in your head? And figuring out the relationship between the two of them is way more complicated. Doing it just trial and error than just doing the algebra. Okay, so sometimes the algebra is way easier. Okay, than trying to figure out the relationship. Okay, like is it being times by 1.4 from one to the other, whatever the case may be.
So also, if you figured out your answer and you got it wrong, could you multiply them by each other and make sure that you can
Always. Yep. So you can always double check because will it be obvious if they're parallel? Yeah. Right? But yeah, you can always check if you're solving for n and you're like, ooh, that looks like a really strange number. You can take the slope that you have, okay, put the answer for n into your slope that's pieced, right? Put it into that. If you multiply them together, absolutely should give you -1. All right. So with that, this is kind of the setup for writing equations tomorrow, but we won't do equations today. I'll give you lots of time to do your practice. So make sure yesterday's is all finished. So you guys went up to page 13 yesterday. So today you're just doing page 14 and 15. And then we can stop there. And then also